Hi, good morning and welcome to reinforcement learning. This first lesson we are going to introduce what is reinforcement learning. Now we will discuss the basics. In next session we will see the elements of reinforcement learning. Today's agenda is introduction about reinforcement machine learning, then definition, some applications, and some comparison of reinforcement learning with other machine learning models that we have discussed in previous lessons. Learning happens through reinforcement of action is called reinforcement learning. That means a human being or an animal learned by continuous interaction with their environment is called a reinforcement learning. The word reinforcement was introduced by the famous psychologist Skinner in 1931 in his personality theories related to psychological studies. Yet, the roots of reinforcement learning is not only limited to psychology, it has some major roots in neuroscience also. Harry Klopp's generalized reinforcement is the base of modern reinforcement learning. In this whole discussion, we will use this generalized reinforcement theory, especially temporal difference learning, to develop a mathematical model for this reinforcement learning. I can define this reinforcement learning is learning what to do and how to map situations to actions. Under reinforcement learning, there are four important points. First thing is about the goal. Goal of learning is to maximize the return. The learner is not told which action to take. That means the learner is just exposed to various available actions. It is his responsibility to discover those actions that maximize his reward. So the key idea is to learn by interacting with the environment. If a learner interacts with the environment provides some rewards. That rewards will become a stimulus. It may be positive or negative. The positive stimulus will strengthen that particular action, and negative stimuli will discourage that particular action. That is the principle behind reinforcement learning in psychology. In machine learning, we try to develop a mathematical model for this animal learning or generalized reinforcement learning. For an example, let us discuss how to learn a child to walk. The psychologist says that there are three distinct steps, namely observation, perception, and expression. So observation means the child will look into his parents and the people around him how to walk. That is the observation step. Second point is the child attempts to get up. That is the first step, to move. Then he tries to balance himself. That means remain still on legs. Then start walking. How will he start walk? First step, that is enough. Then he put the first step, that is walking. A sequence of step creates walk. Definitely walking need something external. For example, if a child set his first feet forward, his parents will clap. Oh, that's great, wonderful, nice. This encouragement creates a positive stimuli. Suppose the child will fall down or sit down unexpectedly in his trial, then what happened? The same parent creates a sound, oh. This whole sound creates a negative reinforcement or a negative stimuli. Then that child perceives this as positive and negative feedback from the environment. If he gets the positive feedback when we encourage that particular baby by balancing on his feet and put forward his first feet, then that baby will repeat the same step. That means repeat walking. Repeat his attempt to walk forward. And also he knows when fell down or sit down unexpectedly, he got a negative feedback or negative stimuli, so the baby will never try to sit down or fell down during his work. So this reinforcement help the baby to learn walking. Walking is a tedious process, we know. That learning will happen with the help of external reinforcement. We can create a mathematical model like this. The below part of this figure shows child, then he tries to walk, then this is the surface, that means the floor. When he attempt to walk, we will give him a chocolate or a positive reward. The reward goes to the child and he will repeat the same. If he repeat a couple of steps, it will create the walking. Walking is a process. That walking will start with a single step, but definitely that stimulus will, or the positive and negative stimulus will help the child to learn walk. The top portion of this figure is the general reinforcement model. Here agent is our child, environment is the surface and the people around the child, then action is here walking. Then when he start first step, we will give some positive reinforcement, that is the reward. The reward goes to the agent and that particular action is strengthened. Suppose that particular action is not that much affirmative, he or she may get some negative reward. The same reward goes to the agent again, but it will discourage that particular action. Here one step to next step or one state to next state. The state can be interpreted in different ways. A child will learn to walk in different situations. For example, in a flat area, climb on steps, and also walking in some slippery area. All these are different states. A child is said to learn to walk only when he know how to walk in all such different situations. So these different situations can be interpreted as states. So formally, the reinforcement learning algorithm can be written in 5 simple steps. First, the agent interacts with the environment by performing an action. Here, stepping a foot to the forward direction, that is considered as a primitive action. In our example, the agent performs an action and moves from one state to another. That performance, that is an action. And the agent will receive a reward. Reward is very important, or a stimuli based on the action it performed. That is our reward. But one important point is that in our mathematical model, we consider this reward as a quantifying value. It is a number, maybe negative or positive, but it is a numerical value. Based on the reward, the agent will learn whether the action was good or bad. If he get a positive reward or a valuable measure, then it is a affirmation that the action is good. If you get a negative reward or some punishment, it is considered as a negative action or a bad action. If the action was good, that is, if the agent receive a positive reward, then the agent will prefer performing the action. That means the strengthening that particular action, or else the agent will try performing another action which results in positive reward. Anyway, this agent is trying to exploit his opportunity. If there is a possibility for a positive reward, then the agent will choose that. Mathematically, we need maximum value. So it's a maximization problem, maximizing the return. In each step, he will get some reward. Sum of all these reward will constitute a return. So ultimately, the agent's aim is to maximize his reward. So basically it is a trial and error learning process, no doubt. But in machine learning approach, we try to develop a mathematical model and we implement this mathematical order in real life situation. That is the purpose of reinforcement learning in machine learning scenario. Then what type of machine learning is reinforcement learning? The agent is learned from its interaction with the environment through continuous feedback. That is a basic idea. The agent or the learner will learn from the environment through continuous feedback and continuous interaction with the environment. Okay. At this standpoint, we try to classify this reinforcement learning into any of our previously known machine learning algorithm. We are familiar with supervised, unsupervised and semi-supervised machine learning algorithms. Unsupervised learning means there is no label. We simply train that particular algorithm with the help of training data. Then the agent, here our agent is the person or the object he is going to learn from this data. They just create a pattern, they identify a pattern from the training data. But in reinforcement learning, there is no identification of pattern. It's just a maximization of its reward. So it cannot go into that particular category, namely unsupervised learning. Similarly, it is definitely not a supervised learning because there is no labeled set. It interact with its environment and create learning from that environment, but with continuous feedback, continuous interaction. Okay. It will not use both labeled and unlabeled data for training or pattern selection. So definitely it will not come under the semi-supervised machine learning algorithm. Then what is really a reinforcement algorithm? A reinforcement learning algorithm learn policies by maximizing returns under feedback from environment. They try to learn policies. How? By continuous interaction and feedback from the environment, and it maximizes the returns. That its aim. Its goal is maximizing return. This agent will choose a policy that maximizes the return. That's all. Hence it can be treated as an optimization problem, but with possible parameterization using machine learning algorithm. That is our important point to capture, because why we people, the machine learning scientists or machine learning people who are focused on this reinforcement learning. This reinforcement learning is a new area, is not a new area. It starting at 1950s or in the 19th century. But what is new here? We are using this reinforcement learning as a top up into the machine learning algorithms. We are familiar with the machine learning algorithms. It will create wonderful results. Then we make use of these results for a parameterization in this reinforcement learning environment. And so that system will become a dynamic one. It will solve dynamic systems. Current changes, current feedback definitely affect the system and its solution. So reinforcement learning will be helpful in that scenario. So the point is that we are using the output of our usual machine learning algorithms to create a parameterization for our reinforcement learning setup. That is our aim. Some of the nice applications of reinforcement learning. The one is education. As we are familiar with computer aided learning, this personalized content delivery and feedback system can be incorporated with the help of reinforcement learning in our new tools or modern tools. Then medicine and healthcare, definitely personalized medical treatment can be implemented with the help of this reinforcement learning. Why we are using such personalization? Reason is straightforward and simple, because nowadays we are treating patients based on the diagnosis. The modern medicine will give medication to diseases, not to patient, but the action of disease on each patient is different. So individualization or personalization is very important in medical diagnosis and treatment. In that scenario, we can use the reinforcement learning. Another one is manufacturing. We can employ robots in very difficult situations. Sometimes the human beings cannot operate some manufacturing area because of the heavy temperature or highly dangerous situation. In that case, we can use pre-trained robots. That pre-trained robots can be managed with the help of reinforcement learning models. Another one is inventory management. The inventory management is actually focused on how the inventory replenishment will be facilitated with respect to the responses from the market. It can be facilitated with the help of reinforcement learning models. Another one is finance. The stock market, portfolio, etc. can be exceptionally managed with the help of reinforcement learning models. Definitely our natural language processing and computer vision can utilize these reinforcement learning facilities so as to maintain the capacity of the system to meet with the dynamic system. Important takeaways of today's lesson are answers to the following questions. The first one is, what is reinforcement learning? Definitely reinforcement learning is learning from interaction with the environment, nothing else. How does reinforcement learning differ from other machine learning paradigms? It's a very nice one. Reinforcement learning is dynamic in nature, and the learning happens by continuous interaction with the environment, so it cannot be come under the category of supervised, semi-supervised or unsupervised machine learning algorithms. It's a new category of learning algorithms. What is the base of modern reinforcement learning? The base of modern reinforcement learning is Harry Kloff's generalized reinforcement theory. What are agents and how do agents learn? The objects that learn from the interaction with the environment is called an agent. And how agent learn? The agent learns with the help of continuous interaction and feedback from the environment. How does the animal learning connect to the reinforcement learning? Reinforcement learning is actually a mathematical model of animal learning or human learning. What are some applications of reinforcement learning? Reinforcement learning model can be utilized in education, manufacturing, inventory management area, and finance, etc., and even in medical area and health science, because of the utilitarian aspects of reinforcement learning. That is, it creates a dynamic system. And in next session we will see the elements of reinforcement learning. Thank you very much.